Okay, last time we studied the curvature of a vector, the space curve. Today we will continue our work with the space curve. We studied the curve, some intrinsic properties of a curve in space, which is given the vector function r of t as a position vector of a moving point, sketching or drawing this curve. We know that r prime of t, the derivative of r prime, gives us the tangential direction or the velocity of the moving particle. And we know that the unit vector along this is capital T, the unit tangent vector, in the direction of increase of the distance of the curve. Now, today we study a new vector n, which is called principal normal vector. Principal normal vector. And another important vector as well, a third vector called the binormal, which is the vector perpendicular to both of the tangent vector t and the principal normal vector n. So let's go with n first. What is the definition of n? How to find the normal vector, the principal normal vector? N is defined as follows. It is the derivative of t. So the derivative of t is normal to t. Why is that? Because t is constant vector. Very similar to the one we studied last lecture when r was of constant magnitude. So this is the definition. Principal normal vector n is defined by t prime, the vector t, derivative of vector t, but we have to divide it by its magnitude, because the t is unit vector, yes, but we are not sure. It's not necessary to get its derivative unit vector as well. So we get a new vector, t prime of t. This vector is perpendicular to n. We need to divide it by its magnitude to get a unit vector. So let's explain here. Why is this perpendicular? Why t prime of t perpendicular or orthogonal to t of t? The same question we had last time when we proved that when r of t is of constant magnitude, then its derivative is perpendicular to it. Okay. The reason is simple, because t of t is constant. In fact, it is 1. But even if it is any constant vector moving such that it has a constant magnitude, then its derivative will be orthogonal to it. It's 1, so it's constant. Therefore, t of t magnitude square is 1 or constant. Therefore, this is, as we mentioned last time, this is the dot product of t with itself. This is the dot product of two vectors. I reminded you with this last time. So d by dt of both sides gives, using the product rule of differentiation, t prime of t dot t of t, this is the derivative of the first time dot the second, plus the first dot the derivative of the second.
Oh, doctor, the screen is frozen.
Okay, I'll check what's wrong.
بس هو كده رجع تمام.
طيب. Is it active now?
I think it's turned off now.
The sharing is turned off now.
Okay. Therefore, the derivative of this constant, of this one is 0. The derivative of this one, which is a constant, gives you 0, which is again very similar to the one we had before, but the other one was about the magnitude of the position vector when it is a constant. So this term is repeated. We have twice this term, to t prime dot t dot t of t, because this dot product thing is commutative. This is 0, therefore this means that these two vectors are orthogonal or perpendicular. Same idea. This is the same thing. T of t is moving like this. Whenever it is, the other, its derivative is perpendicular to it. This is the proof. This is very easy thing to prove. This is repeated idea. Okay. This proves that t prime is orthogonal to t, but does not prove that t prime is a unit vector. So to be sure that we get a unit normal vector, we divide t prime of t by its magnitude. So the vector n is perpendicular to t and of magnitude 1. So it's a principal normal vector. So t is the unit tangent vector, n is the principal normal vector, which is of magnitude 1. Why is magnitude 1? Because we divided it by its magnitude. The direction of t is always in the direction of increasing s. Tangent to the curve in the direction of increasing s. And n, the principal normal vector, will always be in the concave side of the curve, inside the curve, moving with t. At every point, we have the tangent vector, we have the normal vector perpendicular to t. And then the third vector is t. So we have t in b. The frame we have t and n now, and define b as the third vector perpendicular to both of them. Is it frozen?
Yeah, هو بيفريز ويرجع مع لوحده كده.
I think a problem of the connection. Okay, we will. Is it working? Make it again. Okay, if we have a moving frame of three unit vectors perpendicular to each other, the first one is the tangent vector, the unit tangent vector. N is the principal normal. And B is called the binormal. Binormal. Bi means 2, so it's normal to both of T and N, binormal vector. What is the definition of B? It is T cross N. So if T is here, N is here, perpendicular to it, so B is perpendicular to T and B, to T and N, going in the right-hand rule. So we don't go into the right-hand rule in details, but be sure that you write B as T cross N, because the direction is important, because T cross N is not the same as N cross T. We just said that the dot product is commutative, but the cross product is not commutative. T cross N is the negative of N cross T. So if you commute them, it will not commute. It gives you a different sign, give you a negative sign. So we have a moving plane with any space curve. If this is the direction of motion, this is the direction of increase of the value of S, the distance. At every point, we have a unit tangent vector T and a normal vector N, which how to find N? How to find N? We differentiate T to get T prime and divide it by the magnitude of the derivative. Where is B? B is a third unit vector perpendicular to both of T and N. At every point, we have this situation. Is it frozen again? What's going on?
هو السكرين لسه بتتحمل عند الناس ولا عندي بس؟
Is okay. We have S, we have N inside the curve, in the concave side of the curve. We have B B is T cross N. At every point, we have this definition. So we have three perpendicular vector, mutually perpendicular. Every two of them have 90-degree angle in between. But we have a point to prove here is to be sure that to verify that B is a unit vector. So we need to do that. Verify that B is a unit vector of magnitude 1, I mean. This is the unit vector. The proof is easy. We need to write the definition first, T cross N. Therefore, magnitude of B is by definition of the cross product of vectors. Therefore, this is the magnitude of T, the magnitude multiplied by the magnitude of N, multiplied by sine of the in the direction of the normal to both of them. So when we have vector A and vector B, and we have an angle in between, theta, the cross product is defined like this. A cross B is, its magnitude is A, B, sine theta in the direction of the unit normal vector, normal to both of them, normal to their plane in space. You studied this before. So the magnitude is the magnitude of the vector T, magnitude of the vector N, sine the angle in between. But the angle between T and N, we know T and N have 90-degree angle in between. So it's sine 90, which is 1. And the magnitude of T is 1. It's a unit tangent vector. And N is again 1 by definition, you know. See the definition here, the division by this thing. The definition by this thing, the magnitude of T prime, to be sure that we get an unit vector. Sine 90 is 1, therefore we get 1. Therefore, the frame, the moving frame of vectors T and B is formed of 3 mutually perpendicular or orthogonal, easier, orthogonal unit vectors. Mutually orthogonal, every two of them are perpendicular or orthogonal. Unit vectors, every one of these T and B thing is a unit vector. They are important in mathematics, especially in a branch called differential geometry, which is used in navigation of spacecrafts. So these are important. For us, we will study them to find the components of the velocity and acceleration along T and N and B. And we'll see how they are divided into components along this. Before we go into the acceleration thing, let's have an example to practice to find the T and B frame of a given curve at any point. So let's have some example. Find T and B of. So these notations are standard. The unit tangent vector, the principal normal vector, the binormal vector of the given curve. Of the curve given by the position vector as follows. R of T given by, because time sine 2T cosine 2t and t. You know now, you have some experience now to see what is this curve. This curve is participation.
Yeah.
Yes. This curve is known to us. We know this curve by heart now. This
helix.
Helix, circular or elliptical?
Circular.
Circular, yes. When we have same coefficients for the sine and the cosine, it's a circular. And its axis in the direction of z. Yes, exactly. This is circular. Vertical means its axis in the direction of z axis. Vertical circular helix. And we can draw some part of it. Yes. What is required? Find t and b of the curve given by the vector function. This one. So let's work. It's what is t? T is
a unit vector.
Yes, the unit vector is given by, what is the definition of the tangent unit vector? It is the derivative. The tangent is the derivative. In 2D or calculus 1, it was the slope of tangent. Here we don't have a slope, we need to have 3D thing. It's a vector. So it's a tangent vector. What is the definition of T? R prime of T, this is a tangent vector. But we need a unit tangent vector, so we have to divide by its magnitude. So let's differentiate. This is easy. How to differentiate this? We differentiate every component with respect to time t. So it's cosine 2t and multiply by the derivative of the argument. The angle inside 2t gives you 2 cosine 2t. And then the second component of the vector function, derivative of cosine is negative sine, the same angle, but multiply by the inside angle, the derivative of the argument, which is t. So we get negative 2 sine t 2t. This is derivative of t with respect to t is 1. This is the derivative. This is a tangent vector at any time. But this is not necessarily a unit vector. We have to divide by its magnitude. This is the magnitude. The denominator here is the magnitude of the numerator. So how to find the magnitude? We revised this many times now. It's Pythagoras magnitude, the square of the components added together, plus the square of the second component becomes positive, sine square 2t, plus 1. And as usual, this is the thing to be simplified by the famous identity of trigonometry, sine square any theta plus cosine squared, the same theta, we gives you 1. So we get 4. So what we get? 1 over root 5. This is 4 plus 1 gives you root 5 here. This is 2 cosine 2t, negative 2 sine 2t, and 1. This is the first requirement. To find the unit tangent vector to this curve at any time, at any point. How we get this? We differentiate and divide it by its magnitude. This is for sure a unit vector now. Why it is the tangent? Because the derivative is in the direction of the tangent. And this as well is the velocity vector is r prime of t without division. Any question? Part 2. What is required again?
And find the n بقى.
N, what is n? Yes, principal normal vector is, we can write here t as a function of t. You can write this. You can write it this or simply without the t, like this. As the same as n or n of t. Like this is in details, and this is the compact form without the mention of the time. What is the definition of n? We studied this lecture. It is to differentiate t. When you differentiate t, you get a vector normal to t, but not necessarily a unit vector. So we have to divide again by the magnitude of the resulting vector. Got it? The same idea, same thing. So let's differentiate again. Root 5 is constant, so let it be there. 1 over root 5. Same, because it's multiplied by function, so we write the constant and differentiate the function. So let's differentiate the function. We get what? Negative 4 sine 2t. How? Derivative of cosine is negative sine and multiplied again by the 2. Derivative of the angle. Second component, negative 4 cosine 2t. Same idea. The third component,
0.
0, because this is the derivative of 1. This is t prime. We need to find, I didn't divide by t, the norm of t prime yet. So let's divide by the norm of t prime. This is t prime of t. We divide by its norm. Its norm is 1 over root 5, square root of square every component and add these squares. So you get 16 sine square 2t plus 16 cosine square 2t plus 0 square, which is 0. Clearly, we get some simplification here. And this again and again, we meet this identity for sure, which gives you 16. So the result is what? This is 16, common factor, sine square plus cosine square gives you 1. The square root of 16 is 4, so we get 1/4 of this vector. Negative 4 sine 2t, negative 4 cosine 2t, and 0. There is more simplification here. We can take this 4 or negative 4 common factor outside and get the vector negative cosine t, sorry. Negative sine t, 2t, negative cosine 2t, and 0. This is the normal vector at any time. So we may be asked to draw or to calculate a certain point when the time is 0, when the time is pi over 2, when the time is pi over 4, to find these vectors and draw them in the sketch of the given graph. We are done? Not yet. We have a third vector to calculate. Which one?
The binomial.
The binomial vector. B. The binomial vector. What is the definition of that? Binomial means normal to each of t and n in the direction of which is determined by the right-hand rule. The important thing is to write the formula correctly. How to find a cross product of two vectors? We need to calculate some determinant. It's I, J, K thing. I, J, K, and these are the vectors. If you miss these signs for simplicity, no problem. But write the vector notation in I and J and K, or without the I and J and K and in this form, like this one. Like this one. So let's copy these. This is the t. N, where is N? N is there, here is N. So I'll copy these components of t first. 1 over root 5 times 2 cosine 2t. This is the first component of t. Second component of t is negative 2 sine 2t over root 5. Third component is 1. So I'll try to make it symmetric. Write it. 2 cosine 2t over root 5. You can take in the third component. The b, the n thing, the n is here. We don't need to copy, it's up there. Seen here. So we multiply this sort of multiplication of vectors, the cross product, to get the binormal vector. So we always need to compute some cross product of vectors. Like last time, we used it as well in the formula of curvature. So it's an important thing we need to practice. How to compute this? We revised it last time, and the vector notation, I don't need to write. I will compute the I component is this 2 by 2 determinant. You need to expand it in the, apply the main diagonal minus the diagonal. So how to do that?
تبقى negative 2 sine
This
2t.
is 0 in into t. This is the I component, the first component. Again, I reminded you last time, we cover the row and the column 2 by 2 determinant here. Second thing, the J component. So let's go to the J component, cover this row and column, compute the remaining 2 by 2 determinant in the usual manner. The main diagonal to be multiplied, you get 0, you get minus sign by the formula. Sorry, again, we have minus sign plus, there is minus plus. This is of rules in determinants. Plus minus is the minus sign to expand and then multiply. This is the 0. This is the main diagonal minus the other diagonal. So the plus sign to J component. The third and last one is cover the K component, cover the row, we get a big thing, negative 2 cosine squared 2t over root 5. Yes, minus. So it becomes plus. So minus again. Why is that? Because here we have negative sign, here we have negative sign. So their product is positive, and the rule for expanding to what? 2 sine squared 2t the remaining is to simplify. This is cosine to t. This is negative sine to t. So we get negative 2 over root 5 is common plus sine square to t. Yes. And this is the brackets for the closing the vector. So what we have is cosine to t negative sine to t negative 2 over root 5. This is the result. This is I corrected the mistake here. There was root 5 missing in the third component of this vector. So we get this. Okay. You get it, Shabab?
تمام يا سلام.
Okay, there was a little mistake here in this missing root 5 in the third component. I so this was about the thing about this frame at certain point, maybe at sketching these curves and frame T and B at some points. E.g., say T0, T pi over 4, T So, for example, here, R is the at what? R cosine 0 is 1 vector. T at 0 is, what's T? 1 over root 5, some vector 2 cosine 2t, so it's 2. Cosine 0 is 1, so it's negative. Sine 0 is 0. Here is 1. This will be the unit tangent vector. The principal normal at the 0 will be, there is no root 5 here. We get negative sine 0 is 0. Negative cosine 0 is negative 1. And we have 0 here. B will be the binormal at this point. Substitute here for the final result we get root 5 times cosine 0 again is 1. Sine 0 is 0. And here you get negative 2. This is the third requirement. To draw this is the x-axis, the y-axis, the z-axis. The first point of motion. How to know the direction of motion? We need point and another point. So at 0, we have 0, 1. So 0, no, 0, 1, 0. So this is R0. And the curve goes like this and moves. I will know you. This will be enough. This is the direction of motion. This is the initial point. Where is T? T is in the direction 2, 0. So it's 2, 0. So this is the direction. This is the vector T. And the vector N is 0, negative 1. So the other way. N is inside. N is in the concave side of the curve as usual. This is N. Because it's 0, negative 1, 0. So it's in this direction. Where is B? B is normal to both sketch or exact drawing, but rough thing. Approximate drawing. I give you many important points to try by yourself. Any question? Any question يا شباب؟
دكتور أنا عندي سؤال.
اتفضل.
هو احنا عرفنا منين ال 0 1 1 is going to be the initial point?
Okay. When t is 0, I substituted. When t is 0, I substituted in the given function, given vector function R.
Oh,
if you
okay.
consider 0, so the initial point when t is 0. So I substituted here in R to get sine 0, cosine 0, and 0. This is the initial point.
Okay, thank you, Doctor.
Got it?
Yes, thank you.
Doctor, Hana, I don't get how we
Okay.
sketch the curve.
Okay, I did it many times now, but
I don't know how to do it this.
R of t? R of t is sine to t and t. If this is 0 or constant, this will be a circle. Yes?
Yes, I get إن هو it's gonna be a circular helix بس أنا I don't get how to put يعني put the points on the graph.
xy. This is when t is 0, you get 0. Cosine 0 is 1 all and neglected. It would be like a circle in the xy plane.
Mm.
If this t is 0, it's give you a circle in the xy plane. XY plane is because as t moves, z appears. The point drawing this curve will move up in the z direction. So if t bigger than 0 or at z is not 0, will not complete, will not be finished. So we begin here and move and appears. So this circle moves up. Moves up in the space. As than 0, the point increases. 0, 1, 0. No more z is 0 at this point. It moves up and up and up and so on. So it will not be a circle, it will be a moving circle toward in the direction of z-axis. This is the case. It goes like this. How to find another point? Put t equals 2, for example, and we did this in the second lecture. So let's again calculate the point at t equals pi over 2. So r equals at pi over 2 will be sine 2 times pi over 2 is pi, and here is pi. What is this? Sine pi is, what is sine pi is 0. Cosine pi is -1. After some time, we come is 0, y is -1, so it's here in this direction. This is the positive direction of x, this is the y, so this is the negative direction of y. So y is -1, so it's here, and z up here, up there. This is the point p at pi over 2. How to substitute for t equals pi over 2 to get 1, 0. So we go from the initial point up to this point and continue. This is the way.
Okay, thank you.
Got it?
Yes.
Not at all. Welcome. Any other question? So let's go to the second part, how to acceleration vector in the 2 direction or the 3 directions of t and b for a moving particle. In fact, we will have no component along b, but we have, and the velocity as well is all in the tangential direction. But the acceleration is one tangential along t and another normal along the principal normal. What is that? Let's do it. Tangential component. Tangential and normal components. What? Exactly of A, the acceleration. So when we have R, the position vector as a function of t, when we differentiate, we get V, the velocity. This is the position vector. This is the velocity vector. Which is R prime of t. That's it. What about the speed? Speed is the magnitude of V, which is this, R prime of t. So we can write it like this. So V is magnitude of V or R prime of t in the direction of t. It's all in the direction of the tangent. No part of velocity in the direction of normal. The velocity is tangential in the direction of the tangent vector. Or we can write it like this by the formula we have last time, the relation between the arc length and the magnitude of R prime. They are the same. They are the same thing. So we can write here 0 in the direction of n. So it's all. This means the velocity is all tangential. That is along the tangent. No component along n. Along t. All tangential. Second, let's differentiate again. Again, when we differentiate, we get the acceleration. A is dv by dt. So we differentiate what? ds by dt, the vector t. There is no 0 in the direction of n. So how to differentiate a product of two things? We differentiate the first and times the second plus the first times the differential of the second. So the product rule gives you product rule of derivatives or differentials, gives you the following. this is not zero as t is a function of time. It varies with time. The curvature from last time we can simplify this to get and so this is related to the normal vector as well, the principal normal. So the acceleration is given by this second derivative of the arc length t in the direction of t. This is called the tangential component. This is at plus kappa, the curvature we studied last time, ds by dt, the derivative of the arc length, which is the speed again, e square times in the direction of n. So from where this is from the definition of the curvature we had last time. So now we have two components. So the acceleration is in two components. This is at, the tangential component of acceleration. And this quantity is an, the normal component an, a sub n. A sub t is the tangential for t, a sub n for normal. A sub n is normal component of acceleration. So this formula is a bit difficult to use because it asks us to component delaying the curvature calculation to till the end. From where we have this from vector, another formula. This is important and make our calculation easier. Another formula for AT
أنا مش عارف الإنترنت وحش كده إزاي.
So sorry. Triangle of vectors, the tangential component of A plus A, the acceleration gives you the whole vector of A, as usual when we resolve two vectors. So A equals AT and AN, we can use by Pythagorean theorem, AN square is the magnitude of A square minus square by Pythagoras theorem. From this, right, is less signs like this will be easy. Then we can find, and then put it here, and from this calculation we can determine the value of the curvature as well. This is easy, and we can apply in some examples. So let's have some example to see this formula. This is an important formula. And then we can use it to compute. Kappa is better. Kappa ds by dt. Square. Yes, square. Therefore, kappa is n, the magnitude of the normal component divided Okay, an example about this acceleration components given a position vector of a moving particle. The question is to find the tangential and normal components of acceleration at t equals 1. Find the curvature as well. Find curvature. So what to do to differentiate? First, let's differentiate to find the, to speak about acceleration, it is the derivative of velocity. So we have to find the velocity first. Gives you 1, differentiate 2t to get 2, differentiate 2t to get t squared to get 2t. This is the derivative at any time. This is as well is a tangent vector, but not the unit tangent. And the acceleration vector is a of t acceleration as whole, as a vector without resolving. So we need to find, we are asked to find the components of A along the tangent is v dash of t, which is r double dash of t. So we differentiate again. We don't need to write all of this, but I'm explaining as well. So derivative of 1 is 0, derivative of 2 is 0 as well, derivative of 2t